Hello viewers, I'm Kausalya. Today's topic is resistors in parallel. So here, as we all know what is a parallel connection is, a parallel connection is one in which that is one end of the resistors are connected to a common point and the other end of the resistors are also connected to another common point. Okay, that type of connection is known as parallel connection. So here we are considering three resistors, you see, R1, R2, R3, and they are connected between the terminals A and B, right? So here when you look at this diagram, these are all the resistors, right? So one end of the resistor is connected to point A and other end of the resistors are connected to point B, right? So here this type of connection is known as parallel connection, right? So here now what we are doing, we are replacing the three resistors with its equivalent resistance. So here all the three resistors are, that is, they are calculated and finally the equivalent resistance is drawn here and the rest of the things remains the same, right? Here there is a voltage source and there is a current supply, and here the three resistors are replaced by a single resistor. That's why here R is written as RT, total resistance. Now when you look at this diagram, here the voltage is same across all the three resistors, right? That is, the voltage across R3 is V. Similarly, voltage across R2 is also V, and voltage across R1 is also V. So now we are going to calculate the value of currents I1, I2 and I3 by using Ohm's law. So what is Ohm's law? V is equal to IR. So V is equal to IR. We need to calculate I. So I is given by V by R, right? So here I1. So this is your I1. So I1 is equal to V by R1 because the voltage across this R1 is V. Similarly, I2 is V by R2 and I3 is V by R3, right? Now what is the value of this current I? This I is equal to I1 plus I2 plus I3. So write it as a formula. So I is nothing but I can be written as V by R, right? Because I is nothing but V by R. R is nothing but RT. So here I is written as V by R and I1 as V by R1, I2 as V by R2 and I3 as V by R3. Again, here we are taking V commonly outside. So this is our expression. Now these two terms cancel each other and finally 1 by R is given by 1 by R1 plus 1 by R2 plus 1 by R3. Right. So 1 by R can be written as G, that is known by the term conductance. Right. So 1 by R is G. Similarly, R1 as G1, R2 as G2 and R3 as G3. So in parallel combination, the reciprocal of the equivalent resistance is equal to the sum of the reciprocal of the individual resistances. Right. You see, the reciprocal of the equivalent resistance is nothing but total resistance. So the reciprocal of the total resistance is equal to sum of reciprocal of the individual resistances. Right. So here some points to be noted in parallel connection of resistors. So the first point is voltage is same across all the elements. Okay, just now we have discussed the voltage is same for R1, R2 and R3. And the current through the various resistors are different. But here the current flowing through the resistors differs. And here the total resistance is less than the smallest of the resistances. Right. Here the value of total resistance. How we calculate the value of total resistance? Just by making this formula, right? The total resistance is given by 1 by R1 plus 1 by R2 plus 1 by R3. It depends upon the number of resistors which are connected in parallel. So here the total resistance value will be less than the smallest of the resistances. For example, here let the value of resistance be 5 and here let it be 10, let it be some 15, right? So here the total resistance value will be less than the smallest of the resistance. So here among the three resistors, which one is the smallest? 5 ohm is the smallest. So the total resistance value will be less than the 5 ohm. Okay, that is the meaning of this statement. And conductances are additive. What is mean by conductance? The reciprocal of the resistance is known as conductance, right? So here 1 by R can be written as G. So here similarly the G can be written as G1 plus G2 plus G3, right? So that is why these conductances are said to be additive. That is, we can add the conductances. And source current is the sum of the branch currents. That is, when you look back at the circuit here, so what is the source current? So this is your source current I. So this source current is nothing but it is the summation of the individual currents. That is, I is nothing but I1 plus I2 plus I3. Do you agree or not? Because this current I gets divided into 3. So I is equal to I1 plus I2 plus I3. So this is what said in the last point, right? Now we are proceeding with the current division formula. That is how the current gets divided when resistors are connected in parallel. So initially I am considering two resistors which are connected in parallel, right? So the resistors are R1, R2, and accordingly the current flowing through the resistors are I1 and I2. So since this is a parallel combination, as we already discussed, the voltage across this resistor R2 is also V, and voltage across this resistor R1 is also the same V, right? So therefore the voltage drop will be also, it holds the same. That is, since voltage is same, right? You see what is mean by voltage? Voltage is nothing but I into R. So here we are having I1 into R1, that is the voltage across the resistor R1, and similarly I2 into R2 is the voltage across the resistor R2. So therefore I1 R1 is equal to I2 R2, right? In or else you can even consider, let the voltage drop across this resistor be V1 and this resistor be some V2, right? This V1 should be equal to V2. So V1 is equal to V2, therefore V1 is nothing but I1 R1, V2 is I2 R2. So when you rearrange the terms, I2 is given by this formula, I1 R1 by R2, right? So from this diagram again, the current I is equal to I1 plus I2. So I1 plus I2, and here I2 is given by this expression, right? So just replace I2 by this expression, and in this expression the term I1 is common here. So when you take I1 outside, so the remaining term will be 1 plus R1 by R2, right? So finally when you take LCM, it is given as R2 plus R1 by R2, right? So I is given by I1 into this term, but we need only I1. So just rearrange the terms accordingly. So I1 is given by I into R2 by R1 plus R2. Right. Similarly, the value of I2 can be written as this total current I into R1 divided by R1 plus R2. Right. So here we are going to calculate the total resistance of this parallel combination. So the total resistance is given by 1 by R is equal to 1 by R1 plus 1 by R2, right? When you take LCM, R1, R2 forms the denominator part, and here R1 is present, so therefore the numerator term should be R2, and here R2 is present, therefore the numerator term should be R1, right? So 1 by R is given by this expression. When you take reciprocal, the R is given as R1 R2 divided by R1 plus R2. So in words we can write it as equivalent resistance or total resistance, right? That is equal to product of the two resistances, right? Here the two resistor values are getting multiplied. Therefore, product of two resistances divided by again summation of two resistances, right? We are going to add. So this is the simple formula. When two resistors are in parallel, then the equivalent resistance is given by this formula. Right. Now we are going to proceed with three resistors in parallel. So Here also again we are going to calculate the total resistance and as well as the current flowing through each resistors. Right. So here R1, R2, R3 are the three resistors. The first step is we are going to calculate the equivalent resistance. So the formula is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Again you have to take LCM. So the denominator term has R1, R2, R3. Right, since we are having R1, the remaining terms are R2, R3. And here R2 is present, therefore the remaining terms are R1, R3. And here R3 is present, so the remaining terms are R1 and R2. Right. So we need R, so just take the reciprocal. So finally the total resistance is given by this expression. Right. Now again consider this diagram. The value of current I is given by this current I gets divided into 3 here. Therefore, the current I is equal to I1 plus I2 plus I3. Right. And again, this is a parallel combination, right? Therefore, the voltage across R1 will be equal to voltage across R2, that will be equal to voltage across R3. So V1 is equal to V2, which is equal to V3. So V1 is given by formula I1 R1, V2 I2 R2 and V3 is I3 R3. Right. Now we are going to rearrange the terms and find the value of I2 and I3 in terms of I1 here. So first take these two expressions. We need I2. So when you need I2, we are going to move this R2 to the left hand side. So here it is written as I1 R1 by R2. Again consider I1 R1 and I3 R3. Again just calculate the value of I3 here. Right. So the value of I is I1 plus I2 plus I3. So just I2 just replace the value, replace it with this expression, and for I3 with this expression. So in this case again I1 is common. So when you take I1, we will be having an expression like this. Again you have to take LCM. So when you take LCM, the denominator part has R2, R3. Right. So then calculate the numerator terms accordingly. And finally we need expression for I1. Right. So we need only I1. So just shift this expression to the left hand side. So when you move this part to the left hand side, it will come as a reciprocal. So here you will be having the term as I into R2 R3 divided by this denominator part, that is R1 R2. Here I have just rearranged. You see R1 R2 R2 R3 and R3 R1. Right, it will be easy to remember if you write like this. Similarly, write down the expressions for I2 and I3. Right. Anyways, the denominator part remains the same. And again here I remains the same. If you need I1, here the resistors are R2 and R3. If you need I2, then the resistor value will be R1, R3. And if you need I3, then the resistors are R1 and R2. Okay, you can easily keep it in mind. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.